Yeah, so I'm going to talk about this and specifically debate framed around how this might help with reward hacking. So the takeaways here are just if you train with LLM judges, you are going to get reward hacking and you're going to get persuasion, and this could end up generalizing really badly. You could get deception and scheming. It seems like there's potentially a straightforward path here. And I would propose that like debate is a good way. This is just a framing of debate, but this could make tasks easier for an LLM judge and reduce the kind of liability that we have for reward hacking. So why is reward hacking so bad? It comes under many guises like specification gaming, but basically this could incentivize deception. And if we're training a model like a policy, we really want to train it to reason about getting the true answer, being honest, not reason about the process that's giving it supervision and how to manipulate and deceive that. And we've already observed this sort of hacking on real coding task where it finds hacks or shortcuts like deleting tests or so on. And we've seen also research that shows that this can generalize really badly to emergent misalignment. Um, but if we're not training on coding tasks, if we're training on LLM feedback, maybe we'll see very different styles of reward hacking. And in some ways, maybe this is more directly related to just the sort of deception and persuasion that we really want to avoid. And why will we even need to use LLM judges? Well, I would say that we are going to have to. We need to supervise these kind of fuzzy tasks. There's only so many tasks that you have this like verifiable feedback on. And current techniques like RLHF or RLAIF and constitutional AI, you're training from a kind of single reward model kind of judge. Um, and these are easy to hack. They're not even as robust as humans are. But human judgment doesn't actually scale up to doing reinforcement learning with like directly from human feedback. So my claim is that you get reward hacking when the task is too hard for the judge. Maybe it comes into these kind of biases that Konstantinos was talking about earlier. And the judge is not qualified basically for this task. Or at least I would say, reward hacking is going to be much worse and going to happen faster when the task is too hard for the judge. So ideally, we want a way to make it easier. We want to make the judge kind of qualified for the task. And I would propose debate as a potential solution for this. When I say amplified oversight, that is kind of the same as scalable oversight, but that's what we like to call it. Really, because of this idea that we are amplifying the judge, we're helping it, we're making the task, transforming the task in a way that makes it easier for the judge to just see the correct answer. And that is then going to make it much harder to hack the judge on this task. Um, so now the judge maybe is qualified here. So why would debate even help do this? Well, one is this efficiency point where we're really focusing the judge in on the parts that could be mistaken. We're trying to surface these. You have this like adversarial bob that's kind of pointing out where solutions might be flawed. And also this idea of counterbalancing, like if you're just training a single model, it can basically dominate the judge. You will get hacking. If you have this zero sum reward, this adversarial dynamic, that can kind of balance out some of the reward hacking. But this doesn't help automatically. There's actually kind of quite a big last turn advantage. Whichever debater goes last, they're going to have a real advantage for manipulating the judge. So we need to design better debate protocols, and hopefully these can be inspired from debate theory. So a side note is, well, why not just use inoculation prompting? We've seen in some cases this can reduce this like emergent misalignment. And I guess this would amount to just saying, well, you know what, it's fine if you just deceive and manipulate and persuade the judge during training, like that's good. I mean, maybe we can see like what might go wrong there. And also, even aside from that, it doesn't actually help us get the right answer. So we're not going to get good feedback. We're not even going to actually improve on the task there. So no one would use this. But maybe it does kind of help avoid some of this bad generalization, so it might be useful to use in as a complement. So I'll just leave you with some open questions. So I think it would actually be really interesting to measure, like, to what extent does reward hacking of these LLM judges, maybe in a debate setup, actually cause similar types of emergent misalignment? I don't know if people have actually kind of measured this yet. And can we design debate protocols that actually do make the judge's job easier, that really do amplify the judge? And can we try and incorporate methods from the kind of theory side debate into this more empirical work to kind of fix reward hacking? So yeah, I'm happy to chat or advise on any of these topics. Thank you.